Let's practice using implicit differentiation. So the directions here state to find dy dx for sine of xy equals 7y plus 2. So this is what we call an implicit relationship. We can't actually solve for y, so we can't get this into the form y equals, and this isn't a function. If we were to graph it, it would not look like a function. But we still want to be able to take the derivative of this relationship, and implicit differentiation allows us to do that. So whenever you're using implicit differentiation, in the back of your mind, you always want to be thinking of y as a function of x. Even though it's an implicit relationship, we're still thinking of y as a function of x. So whenever we take the derivative of y, so if I were to take the derivative with respect to x of y, it's going to be dy dx. Or some people write y prime. Either notation is fine. And so whenever we take the derivative of an expression involving y, we need to remember to use a chain rule, since y is actually a function of x. So let me show you what I mean with this example. So find dy dx for sine of xy equals 7y plus 2. Okay, so we want to take the derivative with respect to x of both sides. Okay, so the derivative with respect to x of sine xy equals the derivative with respect to x of 7y plus 2. Okay, so what about the left-hand side? Well, we're going to have to use the chain rule on this because we kind of have an outer function and an inner function. We don't just have sine of x, we have sine of x times y. So the chain rule tells us we start by taking the derivative of the outer function. So the derivative of sine is cosine, and we keep the inner function inside. But then we multiply by the derivative of the inner function. So in this case, that's going to be the derivative of xy, and we'll come and work on that some more in a second. Now on the left-hand side, I have the derivative of 7y plus 2. So let's think about 7y first. So the 7 is just a constant. It can just come out front. Then I have times the derivative of y. But we said above that the derivative of y is dy dx. So this is 7 times dy dx. And the derivative of 2 is 0. 2 is a constant. Okay, so let's work a little more on that right-hand side. So we have cosine of x times y, and then I have the derivative of x times y. But x times y is a product, so I'm going to need to use the product rule to take its derivative. So let's put this in brackets. Okay, so product rule is first times the derivative of the second plus the second times the derivative of the first. Okay, so what does that give us? So we have x times the derivative of y. The derivative of y is dy dx, or y prime if you'd like to write it that way, plus y times the derivative of x. Well, the derivative of x with respect to x is just 1. So this is just plus y, equals 7 dy dx. Okay, so we're making some progress here. We finished actually taking the derivative of everything. But let me, on the left-hand side here, multiply this product out. So you could arrange this any way you want, really, but I'll write it as x dy dx cosine xy plus y cosine xy. So I just distributed that cosine to both terms inside the parentheses. And then on the right-hand side, I have my 7 dy dx. Okay, so now we're not done yet. Even though we've actually taken the derivatives, we haven't solved for dy dx. And the directions say to find dy dx. Right now my dy dx is kind of all mixed up in everything. So how am I actually going to solve for it? Well, the easy way to remember to do this is you want to start by moving all terms with a dy dx to one side of the equation, and all terms without a dy dx to the other side of the equation. So in my case, I'm going to, on the left-hand side, have x dy dx cosine xy minus 7 dy dx. So I moved that term that was on the right, I moved it to the left-hand side. And then my equals negative y cosine xy. So I've separated things so that all dy dx terms are on one side and everything else is on the other. What this allows me to do is factor out a dy dx on the one side. So in my case, that's the left-hand side, and I can factor out dy dx. So dy dx times a quantity x cosine xy minus 7, and on the right, minus negative y cosine xy. Okay. From here, there's really only one more simple step. We just need to isolate dy dx, and we do that by dividing both sides by the quantity in parentheses. So here, dy dx equals negative y cosine xy on top divided by x cosine xy minus 7. All right, and now I have my final answer. This is the derivative, dy dx.